Networking is the topic. All right. So in this chapter, we're going to look at networking concepts. We're going to talk a lot about private and public. We'll talk about VPN, direct connect, layers of security, how to secure the network. A lot of cool stuff in this lesson. So let's look at this particular example here, where we have our coffee shop again. So maybe this will be the last chance before lunch to throw more coffee shop puns in the chat. If you have any bad jokes, you are always welcome to throw them in the chat whenever you see the coffee shop on screen. I've been watching very closely, so maybe some have come in and I've missed them. But in this particular example, what we have is we have a fair amount of traffic in the coffee shop, where we have lots of customers coming in. And typically what we want is for the customers to talk to the cashier. We don't want customers talking directly to the barista in most cases, right? You do your order at the counter, right? You make your order at the counter. The cashier rings you up, you pay for it. The barista, gets a little sticker that prints out and sticks it to your cup and starts making your coffee. But you're not supposed to give your orders directly to the barista, right? You give your orders to the cashier. Well, a lot of applications work this way too, right? A lot of applications work this way too, where we have components of the application we want our customers interacting with. We have other components of the application we don't want them interacting with. All right, I just saw a new one. Yeah, parking the camel. Well done. Thank you, Michelle. Yeah, I'm groaning. I'm groaning right now, right? It's a groaner. Yeah, I see another one. Yeah, The Green Knight. I saw that movie. It was a little confusing for me. I don't know if you saw that movie or not. I guess it's based on a poem. So maybe you're talking about the source material, but I saw that movie. It's a very artistic movie. I kind of liked it, but I don't know if I loved it. Yeah, no soup for you. All right, so let's get back to computer world. All right, so let's take this concept that I just drew out, that we have components of our application we do want the customers to interact with. We have other components we don't want customers to interact with. For example, I have a website that you can browse. I want you to be able to interact with that, but I don't want you to interact with the database that stores our orders, right? Just as an example. I want you to be able to browse the website and order things from my store, but I don't want you interacting with the database that stores the orders. So the way we accomplish that in AWS world is we build something called a VPC, and then within it we build subnets. All right, so let's look at this picture. So inside of AWS, we build something called a VPC. As you can see on the screen, it stands for Virtual Private Cloud. It's a network. It's a network. That's all it is. Okay. When you have servers expect to be able to talk to each other, right? So servers, at least when you're building servers on-prem, you plug network cards into them and you run network cables. The network cables go to switches and routers and you interconnect all the servers. They have a network they can use to communicate with each other. Well, in the cloud, everything's virtual. You're not going to be running physical cables between network cards and servers and switches and routers, right? Everything's going to be virtual. And the VPC is that virtual network. All right, so maybe if I say it this way. In AWS, you create a VPC and you start putting your servers in it. When you create your EC2 instances, right, those virtual servers known as EC2 instances, it asks you in the wizard which VPC you want to put the servers in. Well, when I put all these servers inside this VPC, then they can talk to each other. They have network connectivity. It's the same thing. It's the cloud version of running cables between the servers. You just create a virtual private cloud, a VPC. It's pretty easy, actually, compared to running cables, right? You create a VPC, put your servers in it, and we do the rest. We connect the servers to each other. VPCs are private. Okay, they are private. I saw a question go by earlier in the chat that I went ahead and let one of our chat support people answer it. but I'm going to reiterate it right now. One of the people was asking, remember when I was talking about how you might have a host computer in the cloud, and I might put my virtual machines on it, but it's going to be shared with other people's virtual machines? But each one of our virtual machines is inside different VPCs. My virtual machine is in my VPC, which is private. Okay, so when your virtual machines are in the cloud, they only have network connectivity with other virtual machines that are in the same VPC as your VPC. Okay, so I'm just saying, my virtual machines and that other customer's virtual machines can't actually see each other because we're each inside of our own VPCs. So even when you put virtual machines in that shared solution, no security issues there, right? It'd only be if you had, regulatory requirements or something like that. You might go with that dedicated instance or dedicated host options. Okay, so I have this VPC. Then within the VPC, there are areas, servers made within the VPC that I want the internet to be able to get to. There are other servers that I don't want the internet talking to. Kind of like the counter area in my coffee shop, right? I want people talking to the cashier, but not to the barista. So inside your VPC, we can create what we call a public subnet. We can actually have several public subnets. We're not limited to one. And we can also create a private subnet. The idea of a public subnet is it would be exposed to the internet. Private subnet would not be exposed to the internet. So maybe I put things like web servers here that my internet people can interact with, my internet customers can interact with, but maybe the database server who stores my orders would be on the private subnet. All right, we see a better picture of what I'm drawing here on the next slide. All right, so inside of VPC, you create subnets, and those subnets can be public or private. And so some servers might be placed in a public subnet in order to expose them to the internet. Other servers, in this case, have database servers. They're, in this case, residing in a private subnet, so I'm not exposing them to the internet. All right, so a VPC, just to summarize, is a virtual network. Within that virtual network, we can create subnets, and each subnet can be either public or private. Then when I start building new EC2 instances, every time I build a new EC2 instance, it's going to ask me, where do you want to put it? That's a bad looking question mark. Let me try that again. That looks a little bit better. But it's going to ask me, which VPC do you want to put the EC2 instance in? And within that VPC, which subnet do you want to put it in? So I have control over which servers running which applications are exposed to the internet, which ones aren't. If I go back into my console, I'm just going to show you that there's an option here when you go into services, right? We have all these services. I actually have this service added to my little shortcut bar here, VPC. And then you can see what it looks like to create a VPC. I'll just, click on the button real quick so you can see it. That question just came in the chat, and I wanted to demo it anyway. But there I am creating a VPC. Actually, you know what? Let me go to a slightly different screen. But there I am creating a VPC. Actually, you know what? Let me go to a slightly. So you create a VPC and you give the VPC a name. You give the VPC a name. So you create a VPC, you give the VPC a name. You give it an servers are going to expect that IP address. You give it an IP range. You assign an IP address range. Servers are going to expect as you build servers, AWS will assign an IP address range. Those IP addresses. And then as you build servers, AWS will automatically. And then within the VPC, once the VPC is created, you see another option here on the left to create. And then within the VPC, once the VPC within your VPC, you see another, as you can see on my screen, it designates you start creating public or private. Okay, I think I'm going to stop here. We really need to take the lunch break. It is 12 Mountain Time, so it is the time I promised we would take our lunch break. So when we come back, we'll talk about Internet Gateway, we'll talk about virtual private gateway, some other network services, and then we're going to talk about storage, security, and then we're going to start seeing the chapters will start going a lot faster. Right? Once we get past like module 5 or 6, then the chapters start getting a lot faster. A lot of these concepts in the early chapters are foundational, and we spend a little bit more time on them. But we'll kind of pick up the pace a little bit in the afternoon. All right, so we don't want to actually make the database where those orders are stored available to internet users. There's no reason for that. And for security reasons, we'd rather keep that private. All right, so that's just a quick review. Now, let's move into some new stuff. Okay, so when you have a VPC, one of the things you can do is you can put an internet gateway on it. Let me go back into my console for just a second. And you can see that when I'm in the VPC area of my console, on the left-hand side, there's an option for internet gateway. I'm not going to try to create one right now, but you can at least see where it is on my screen. And what an internet gateway does is it provides internet connectivity. All right, so let me quiz you real fast. Real quick quiz question. What does the P in VPC stand for? The letter P, what does that stand for? Private is the answer. Yeah, it stands for private. So at least by default, your VPC is private. It's not connected to the internet by default. When you set up an internet gateway, then we have internet connectivity. But until then, there is no internet connectivity, right? We force you to make the internet gateway, right? For security reasons, we prefer that your VPC be totally private by default, right? So when you make a VPC, it is private by default. It's not until you add an internet gateway to it that you have internet connectivity between your public subnets and the internet. All right, what else can we learn about networking? So let's say that you have an on-prem network. So in this particular picture, you can see on the right-hand side, we have a VPC. And on the left-hand side, we have our on-prem network. All right. So what if I want to connect the two, right? I mean, this is super common, right? You're going to create resources in the cloud, and maybe you have database administrators who work in your building. So these database administrators want to be able to manage those database servers that are sitting inside of a VPC. And now, of course, this is a private subnet, so we don't want the internet talking to those database servers, but I want my database admins to be able to get in. So I'll put an X here to kind of block that traffic. But I want my database admins from my on-prem data center to be able to get in and manage those database servers. So I want to create some kind of connectivity between my on-prem network and AWS. There's actually two ways to provide that connectivity. The first, if I erase all my little scribbles here, the first is to do a VPN, okay? On the AWS side, you can create what we call a virtual private gateway. On your on-prem network, you would set up a VPN appliance. Now, this VPN appliance would be something you would purchase from a vendor who sells VPN appliances. So we're talking about companies like Cisco and Palo Alto and Barracuda, organizations like that. And then what you can do is create a VPN connection between these two. Maybe, at least for the AWS side, I can go into my console for just a second. I'll erase all my scribbles here. I'll go back to my console for just a second and show you that over here on the left, you can find virtual private gateway. If you wanted to make one, this is where you would start the process. It's right there, virtual private gateway. All right, and you create a VPN connection between the two appliances. All right, so once that VPN connection is up and running, then you have your on-prem database admins communicating with servers that are in the cloud by passing through the VPN connection. Right, VPN connections are encrypted, so we don't really have any security concerns here. But in this scenario, we would be crossing the internet. The traffic may be encrypted, but it'll be crossing the internet. Since we're crossing the internet there, we may have some objections, especially when it comes to speed, right? The internet can fluctuate a lot in terms of speed. Sometimes you get really good performance on the internet, sometimes you don't. And so some people prefer, rather than using this VPN solution, option number 2 is to do direct connect. Okay, with direct connect, you get a WAN link directly between your data center and Amazon. Okay, so this is a WAN link provided by a service provider, right, in your area, right? So you would contact a service provider in your area, and they basically create a WAN link, so you end up connected to this direct connect location, which then connects to the Amazon backbone. So what's nice about this is we're not crossing the internet, right? It's a dedicated WAN link, and so if you pay for, I don't know, let's say you decide to pay for a gig worth of bandwidth, you can go faster But in this example, let's say you decide to pay for a gig worth of bandwidth. Well, you actually get that gig of bandwidth all the time, right? When you're crossing the internet, like I said, your performance levels can fluctuate a lot. In this case, you have a link that's dedicated to you. There's nobody using that link but you. So you get a much more stable, reliable service, but it does come at a higher price point, right? It's more expensive than the VPN option, but it is a nicer solution. All right, so let's look at some terms and definitions here, see if we can do some matching. So number one is isolate databases containing customers' personal information. Whether you use a public subnet, a private subnet, a virtual private gateway, or AWS Direct Connect to achieve that goal. Yeah, I gave you a couple examples where I was saying that a database server maybe would go on a private subnet. So I'm starting to see some B's there in the chat, and B is correct. Good job. All right, I want to create a so now I'm looking at number two. I want to create a VPN connection between the VPC and the internal corporate network. Which would I use? All right, this time I'm starting to see the letter C a lot. Yeah, in order to create a VPN connection, we would use a virtual private gateway. Once again, good job. All right, support a customer-facing website. We're down to A or D now. Would you use A for a customer-facing website or D for a customer-facing website? And I'm starting to see some answers come in. It looks like A is the popular answer. Well done. If you answered A, you are totally correct. And then, of course, by process of elimination, I don't think we have to even answer the last one. But to establish a dedicated connection between an on-prem data center and the VPC, we would use Direct Connect, right? A dedicated WAN link. So that one will be D. All right, up next. So one of the things that a lot of people have concerns about, of course, is security. All right. You probably have teams of people at your work who are responsible for security, and they're always worried about, and justifiably so, right? Worried about breaches, data leaking out, getting hacked, ransomware attacks, and all kinds of awful things that can happen. And so what we're going to do next is we're going to look at least a couple security features. We have a whole chapter on security coming up. But in this chapter, we'll look at just a couple security features, one called network access control lists and one called security groups. All right, let's start with this picture here. So what I see is a VPC over here towards the right-hand side. And inside that VPC, I have a public subnet. And it appears that I have at least a couple servers in that public subnet. We're going to assume that we have an internet gateway here. Right? It looks like we have internet connectivity, so we're going to assume there's an internet gateway. So people on the internet, of course, can get to those servers. But you know what? Let's say that these servers host a website. Well, if they host a website, then the communication we want to support comes in using HTTP, port 80, or maybe HTTPS, if we're doing encrypted. In that case, it would be port 443. And so I start thinking, well, you know, that's all I want to allow in, right? From the internet, I don't want to allow other things in other than those port numbers, because that's really all that runs on these servers that internet people need to be able to get to. So we can create what is called a security group. A security group is just a traffic filter. It allows you to build rules, let port 80 in, you know, let port 443 in. And then maybe, you know, I don't do any other rules, so everything else is assumed to be denied in that case. And now when people communicate with those servers, they can only use those port numbers, right? There may be other applications running on these servers that hackers could take advantage of. But now they can't connect anything other than these port numbers. So all they're ever going to be able to see is the website hosted on the web servers. All the other services and applications running in the operating system of those application servers would be blocked. All right, we'll call it a security group. Let me erase my scribbles here. All right, so when a packet comes in, we can, might hit that internet gateway. And then we also have a network access control list, right? This is a new item that I haven't mentioned yet. And a network access control list does the same thing as a security group. It's a traffic filter. Permit these ports, block those ports. The big difference, though, is you kind of see based on the picture that the security group is attached to the instance, while the network access control list is attached to the subnet. So the network access control list would filter traffic going in or out of the entire subnet. It would apply to all the servers within the subnet, while a security group attached to an individual server just applies to that one server, that one EC2 instance or virtual machine. Okay, so sometimes you want to filter traffic for the entire subnet. Maybe you have a group of servers who all have the same needs. You do a network access control list to filter traffic for the entire subnet. Other times, though, you might have situations where, I want to let port 80 in on this server, but not on that server. So you can do two different security groups, one that allows port 80, one that doesn't, and attach them to the two different servers. So this gives you a lot of flexibility in how you do your rules. So the network access control list, as I said, is a traffic filter that applies to a subnet. Okay, there's actually, when you create a new VPC, a network access control list comes with the VPC, but it doesn't block anything. The one that comes with your VPC doesn't block anything. But if you make your own network access control list, at least by default, it will deny all inbound traffic and all outbound traffic. Okay, so when you make your own, it'll start by denying anything, or denying everything, I should say. But again, you can make your rules to decide what you want to permit or deny. Now, another thing that's important to know about network access control lists is they are what we might call stateless. We'll see that on the next slide here, stateless. All right, if you're not familiar with what that term means, it just means that we're going to check in both directions. Okay, so here's an example where somebody is coming into the country and passport control checks their passport. And then when they leave the country, we check their passport again, right? So we're checking both inbound and outbound, right? When you come in and out, we check in both directions. And network access control lists work this way. They are stateless. So in other words, all traffic that you want to allow in and all traffic you want to allow out has to be explicitly allowed in your list. You have to make rules to allow that traffic in or out on both sides, right? So you make inbound rules and you make outbound rules. If you don't do any outbound rules, then your servers won't be able to reply. All right, let's go back to this picture, back a couple slides here. Okay, so imagine somebody on the internet connects to one of your servers and you allow that traffic in. Well, then when your web server tries to reply to that user on the internet, you have to let that traffic out, right? If you don't let it out, then it can't get out. And so, this user might have successfully actually connected to the server, but they never get any response back from your server, right? If you don't let this traffic out, they never get response back, and so they're just going to get, an error in their web browser eventually. So the network access control list, you have to explicitly allow that reply traffic back out. It's what we call stateless. All right, but here we see security groups. So these are the ones that you assign to the individual servers. Okay, when you create a new security group, let's just try to remember this over here. If you create a new security group, it'll deny all inbound traffic by default, but allow all outbound. You can modify the rules once the list is created. You can, modify the rules however you want. But that's just going to be your starting point when you create a new list. Deny all inbound, allow all outbound. And one of the big differences with security groups, we already have one difference that we covered, which is that security groups get assigned to individual servers. But security groups are also stateless. I'm sorry, stateful, stateful. Network access control lists are stateless, These are stateful. So it's more like this door attendant, okay? Like imagine you go, to a concert, and when you go in, they check your ticket, right? When you go in, they check your ticket. But when you go out, they don't need to check, right? When you go back out, no need to do a check. Let me advance the slide there. All right, so you can just kind of go back out. All right, so stateful, if I advance the slide one more time, so here you can see a security group. So what's going to happen here is if you allow, let's say that on the security group, you allow port 80 in, and I connect all the way into your web server using port 80, the security group automatically knows to allow the reply traffic out. You don't have to make a rule for it. It'll know to allow the reply traffic out because it's stateful. While network access control lists are stateless, for that type of traffic filter, you have to make a rule to allow the traffic back out. All right, so we just covered two big differences between network access control lists and security groups. One is assigned to subnets, that would be the network access control list. Security groups are assigned to individual servers. Network access control lists are stateless. They don't automatically know to allow reply traffic out. You have to explicitly allow the reply traffic out. While security groups do automatically let the reply traffic out, and we call that stateful. All right, good. Maybe if I go back one more time to this picture before I advance to some other topics. If both are in place, right? If you do both a network access control list and a security group, and let's say I'm out here on the internet trying to connect on port 80, I'm trying to connect using HTTP, then the network access control list would have to allow port 80 and the security group would have to allow port 80, right? If either one of them blocks the traffic, I would end up getting blocked. Good. All right, let us move on. All right, so network access control lists, as we just decided, are like little firewalls, little traffic filters for your subnet, and they're stateless. Security groups are traffic filters for your individual EC2 instances, and they are stateful. All right, I think we've covered that now, and I think we are ready to move on. All right, excellent. So let's move on and talk about DNS. All right, so DNS stands for Domain Name System, DNS, Domain Name System. And I'm sure there's a lot of people in the room who already know what it does, but for those of you who have never heard of it, or maybe you've heard of it and never heard a good explanation, let me give you an explanation right now as to what DNS does. Okay, when you are communicating on the internet, all right, so here's me, here's the web server I want to connect to. Let's say I want to go to a website like Amazon.com. I want to shop around on the Amazon store. So I'm going to go to that website. So what I do is I go into my web browser and I type Amazon.com on my web browser. All right, but my computer doesn't know where that computer is located, the computer I'm trying to connect to. Right, I just type Amazon.com on my web browser. So what actually happens is my computer sends a query to DNS. Maybe I'll just use this picture of a DNS server here. So I send a query to a DNS server, and it looks up the IP address of Amazon.com. So I say, hey, here's the name I'm looking for. And it returns the IP address, right? So I send the name, it looks up the name and tells me the IP address, and then my computer uses that IP address to actually connect to the website. So what does DNS do? It resolves names to IP addresses. Right? Every time you try to connect to a website, you type in the name, and DNS resolves that name to an IP address for you. You can think of DNS like a giant phone book, but instead of names and phone numbers, it has names and IP addresses. Right? It's like a giant phone book with names and IPs instead of names and phone numbers. All right, so in this case, we have somebody who's going to maybe make a DNS query. Maybe what I'll do is instead of drawing my own arrows, I'll just advance the slide because I think we have arrows built into the PowerPoint here. So I might go talk to a DNS server, and then oftentimes what will happen is one DNS server might have to go talk to another DNS server. All right, as you might imagine, on the internet, there are a lot of names and IP addresses. Right? Millions and millions and millions and millions of names and IP addresses. And so oftentimes some of that information is stored on different DNS servers. For example, one DNS server might have all the .com records, another one might have all the .gov records, and another one might have the .net records. So oftentimes you go and ask a DNS server, and it might have to go ask another DNS server, but eventually what comes back, once again, is an IP address, right? You ask the name, and what you get back is an IP address. If I advance the slide one more time, I think we can see the IP address coming back now. All right, whoops, I guess that's it. So the IP address would kind of come back. I guess we're missing that last arrow that would eventually come all the way back to the client. All right, so that's just a quick look at what DNS is, domain name system. We've been doing DNS since 1984. If I remember correctly, that was the year DNS was kind of invented. Okay, now in Amazon world, we offer a DNS service. The name of our DNS service is called Route 53. All right, so remember we have 200 plus services in AWS. We've learned about a few of them already: ECS, EKS, Fargate, Lambda, EC2, VPC, right? Well, here's another new one, Route 53, and it's a DNS service. So you can use it to register your names and IP addresses so people on the internet can resolve those names to IP addresses and find your applications, right? So it's going to help route internet users to your applications on the internet, right? You can manage your own DNS records and domain names, right? It helps users who are outside of AWS kind of connect to your infrastructure, right? Helps them find and resolve the names to IP addresses that you want them to find. Notice on the next slide that oftentimes we kind of use these two services in conjunction with each other. You might remember that CloudFront from before lunch is a content delivery network. Remember, that's the one that does all the caching of content in edge locations. So maybe instead of connecting people, let's say you have a video library back here. And instead of people maybe connecting to the video library directly, because maybe this video library is hosted in the Oregon region, but you have a lot of users in Australia who are trying to use your service, and they get very slow playback for those videos when they connect to them. So maybe what we do is we want to send them to CloudFront instead, right? Because CloudFront then can cache. So there's a edge location. There are edge locations all around the world, but there's edge locations in Australia. And so the user ends up connecting to an edge location in Australia, and we go and retrieve that content. It gets cached, and it's nice and fast. Everything's great. All right. But how do we send our users to CloudFront? Well, we just play a trick in Route 53, right? When they ask for our name, instead of giving them the IP address in the video library, we give them the IP address of CloudFront. We actually just map to another name called cloudfront.net. And that way, what will happen is these clients end up connecting to CloudFront instead of trying to connect to the origin. I'm going to erase all my scribbles because it's looking a little ugly. So again, users end up, they talk to Route 53 and we say, you know what, go connect to CloudFront. And then they connect to CloudFront instead of doing this and connect to the origin directly. All right, neat. Let me go ahead and erase my scribbles. And here you can see, right, maybe the origin location. In this case, the origin location is a bunch of EC2 servers who are maybe hosting web pages or video files. All right, knowledge check. Here we go. First quiz of the afternoon. Which component or service can be used to establish a private dedicated connection between a company's data center and AWS? I'm going to help you a little bit. The key word in that question is the word private. All right, I'm starting to see some answers. Since it's a private connection, then I think we're talking about direct connect. Choice C, right? We're not crossing the internet, right? So I'm thinking direct connect, right? That's the one that gives you a WAN link between your on-prem network and the VPC in the cloud. All right, let's do another one. Which statement describes security groups? All right, one of those is a true statement. I told you by default what's allowed or not allowed. Let's see if anybody remembers. So if I make a new security group, which rules are by default allowed? Which ones are not allowed? Which one of those statements is true? All right, I'm starting to see some answers here. So if you answered B, this is a tricky one, but a lot of you did answer B. And if you did, good job. They are stateful. Network access control lists are stateful. I'm sorry, I just said that wrong. Let me say it again. Network access control lists are stateless, excuse me, but security groups are stateful. And they do deny all inbound traffic by default. They allow all outbound and they deny inbound. Of course, once the security group is created, you can modify the rules however you like. That's just the starting point when you create a new group. So the correct answer is B on that one. That's a tough one. Let's do another one. This one I think is a little easier. Which component is used to connect a VPC to the internet? Anybody remember? All right, I'm starting to see some people answering as choice A. And if you typed in A, you are correct. An internet gateway connects a VPC to the internet. Good job, well done. All right, one more. Which service is used to manage the DNS records for domain names? So what's the name of the Amazon service that does DNS name to IP address resolution? All right, I'm seeing some D's in the chat. That is correct. It is Route 53. Route 53 is the name of the Amazon service. Provides name to IP address resolution. All right, and I think I gave you a really good clue on the next one now. Which statement describes DNS resolution? Right? I just said it about 5 seconds ago. Yeah, I like what I'm seeing. I'm seeing a lot of D in the question and answer area, and that is correct. DNS does domain name to IP address resolution. So when somebody types in a domain name, DNS is the service that's going to give them the IP address that they need to connect to. And so I can point people to whatever IP address I want by creating DNS records inside of Amazon's Route 53 service. All right, let's move on. End of chapter. So in that chapter, we talked about VPCs. We talked a little bit about CloudFront and Route 53. And let's move on to a new chapter. Let's get those slides out of the way. And as always, you're going to have to give me just a couple seconds to switch my PowerPoints to the new PowerPoints. And now we're going to talk about storage and databases. All right. So in this chapter, we're going to talk about storage. We have a few different storage services in Amazon World. One is EBS. The most famous is probably going to be this one here, S3. We'll also talk about EFS, and we'll talk near the end of the chapter about some database services too. All right, but let's get started with storage. So in storage world, there are three major types of storage. Now, there's also databases, but we'll save databases until later in the chapter. We're not going to worry about them quite yet. But these are storage types that can store files. All right, so I have video files, MP3 files, JPEG files, spreadsheets, Word documents, PowerPoint files, whatever. You have files, and I want to be able to maybe store them in the cloud. Well, we offer three different types of storage for files. All right, the first one is block storage. So this is the one we're going to talk about first. We'll eventually come back to the other two. All right, but let me start with block storage. Okay, you know how your computer, let's say I have a PC, maybe you have a Mac, but that computer has a hard drive, right? And when you take a file and store it on the hard drive, it takes that file and chops it up into little tiny blocks, right? And stores them on the hard drive, right? You have little blocks, right? Kind of stores them on the hard drive. That's block storage. So that's traditional hard drive storage. That's the kind of storage we've been doing since the first time you had your own computer, block storage. We provide block storage in AWS to support EC2. So like I said, I'm going to come back and talk about the others in a few minutes. All right, I'm going to skip these for the moment. All right, let's just focus on block storage first, then we'll come back to the other two in a few minutes. All right, but block storage is what we use in EC2. So when you create an EC2 instance, that EC2 instance is given what we like to call an EBS volume. A lot of people might call that a virtual hard disk, right? Just to use a non-Amazon term, they might just call it a virtual hard disk, right? Anybody who's ever worked with VMware has worked with VMDK files, or Hyper-V, we have VHD files, right? Same kind of idea, right? Because when you create a virtual machine, an EC2 instance in the cloud, it has an operating system, and the operating system expects to talk to a hard drive, right? This EBS volume is a service that appears to provide what looks like a hard drive to your virtual machine operating system. All right, so your virtual machine has this EBS volume. So in other words, if this was like a Windows virtual machine, this EBS volume would kind of act as my C drive, right, where I can store files. Right, we call that block storage. When we create an EBS volume for you, the EBS volume is stored in one availability zone. All right, it gets replicated within the availability zone, but it is stored once within the availability zone. All right, let me go ahead and advance my PowerPoint slide here now. And you can see another option that we offer called instance storage. All right, so with EBS, what I just discussed, your virtual machine gets what looks like a hard drive. With instance storage, your virtual machine, your EC2 instance, gets what looks like a hard drive. All right, so this instance store volume might act as the C drive for my Windows operating system. All right, but here's the deal. When you turn the instance off, when you stop the instance, when you turn your virtual machine off, you lose what's on the instance store volume. Okay, when the instance is stopped, we delete what's on the volume. All right, so with this volume type, there is no data persistence. With an EBS volume, right? So I'm saying there's two different options here, right? When you make an EC2 instance, you can do it either way. With an EBS volume, your data does persist, right? So here's the EBS volume, right? I turn the instance off, right? I stop the instance, and the EBS volume is still there, right? So if I turn the instance back on, my data will still be there. Okay, so with instance store volumes, they provide what we might call non-persistent or temporary storage space. Right? Instance store volumes provide non-persistent or temporary storage space, while EBS volumes provide persistent storage. All right, in most cases, I'm going to guess here. It's hard to know what everybody is going to need, right? Everybody's use case scenario is different, but in most cases, we're probably going to go with EBS volumes, right? We want to be able to turn the instance off and turn it back on and have all the log files and other things. Like, I don't know, I'm running a database on a virtual machine. I want the database data to still be there when I turn the virtual machine back on. So in most cases, we'll probably go with EBS volumes. But, you might have an instance where you're creating a server that's just a temporary server. Maybe you have an auto scaling group where remember those auto scaling groups where we add and delete servers dynamically? Maybe there's nothing there that you want to keep. Maybe the application you're running is very stateless. There's nothing there that I need to keep. And so when I turn the instance off, I just want to throw the data away. You get to pick, right? We offer both options. You can pick which way you want to go. Another thing that's available with our elastic block storage system is a snapshotting feature. I think of a snapshot as a backup. Right? I think of it as a backup. So you can create a snapshot of one of your EC2 instances. Now, maybe I'll just so you can kind of see it in the console. Sometimes it's nice to be able to see something visually. All right, so if I go in here to EC2 and I go down under volumes, right? So these are my EBS volumes here. Right, so these are the EBS volumes being used by my virtual machines. And then right below it, you can see an opportunity to create snapshots. So when I create a snapshot, of a virtual machine or its EBS volume, it's like creating a backup of the entire virtual machine, of the entire EC2 instance. That way, if something bad happens in the future, right, I have this snapshot that I can restore. All right, so it's kind of a nice way to back up your virtual machines in the cloud. Snapshot. Okay, so the two big volume types we have to choose from are EBS volumes and instance store volumes. EBS volumes would keep multiple copies of your volume within one availability zone, and that data is persistent. Okay, with instance store, all right, non-persistent or temporary storage. All right, we shut down the virtual machine, anything that's stored on that volume is gone. All right, those are the big differences. Okay, let us move on to the next issue. All right, so like I said, there, instance store are not ideal for keeping data long-term. All right, let's move on to the next storage type. So another type of storage that we provide in the cloud, if you want to use it, is object storage. All right, what's kind of a hassle is if you wanted to, let's say, store some video files. We see video files here. So let's say I want to store some video files in the cloud. Well, I suppose I can make an EC2 instance, and that EC2 instance has an EBS volume. I can store the video files there. But now I have a server I have to manage. Right? Now there's a virtual machine in the cloud that needs to get patched and updated all the time. Right? There's an actual virtual machine in the cloud that I have to manage and maintain. I have to do server administration. But we offer a service known as object storage, which is serverless. Okay, object storage, or S3. Okay, the name of our object storage service is called S3, Simple Storage Service, SSS or S3. It's serverless. And it stores files. So what we're going to store is we're going to store the file itself, some metadata, some descriptive information about the file, and then each file will have a key, like an ID, that identifies that file uniquely. So this service, known as the Simple Storage Service, or S3, right? It's three S's in a row, so we often just call it S3, Simple Storage Service. Like I said, it's a serverless service that can store these objects, store files as objects. You still have the ability to control permissions over the objects. You can encrypt the objects, right? Sometimes encryption is really important for compliance sake. You might be in an environment where your data has to be stored in an encrypted format. Otherwise, you are violating the security policy of the organization. So we have those kinds of security controls available for us. And we also have these storage classes. Let's not get lost in the weeds on storage classes until we get to the next slide, because that's where we're going to cover storage classes. There we go. So there's the next slide. So I'll just go into my console real fast and show you where this is located. Again, I always appreciate when I'm taking classes if people can show me things sometimes. I think it kind of makes things more concrete for me if I can see it. So these are what we call S3 buckets. All right, so I'm in the S3 service right now, and these are S3 buckets. Buckets are just containers in which we store objects. All right, well, maybe what I'll do is I'll go and I'll open one of these containers known as a bucket. I'll open one of these, and you can see some objects being stored there. Right? They're really just files, but we call them objects. Right? So there's some files being stored there. And I want to show you that when I go to one of these files or objects, that I can change the storage class right there. We have these storage class options here. I'm seeing standard IA, one zone IA. All right, well, let me minimize, and that's what we're talking about here on the PowerPoint slide. All right, so there you see storage class, and if I advance the slide, you can see more storage classes on the next page here. All right, but let's talk about what storage classes are. Let's just start with these two. We'll compare these two, and we'll add in the others. Okay, so let's say that I'm going to put objects in the cloud. Now, what we do is when you store an object in the S3 service, we automatically replicate that data across 3 availability zones. So any files that you store, right? I just showed you a bucket, right? I just showed you some files sitting in my S3 account. Those files are stored in 3 availability zones. So the data should be available to me even when an availability zone fails, which is really nice. Right? It's part of the service. Right? We'll store the objects in 3 availability zones for you. But let's say that your users don't access the data very often. Maybe they do, maybe they don't. But let's say in this case, in my made-up example, I have those files sitting in my S3 bucket, and my users occasionally access those files, but not very often. So I start thinking, boy, Amazon, since my users don't access the files very often, how about you make the service cheaper? Well, there you go. That's IA, infrequently accessed. What we do is if you put objects in this storage class, so when you put objects in S3, you can use any storage class you want. If you put objects in this storage class, what we're going to do is we're going to lower the price of the storage. We're going to make the storage space cheaper. But we're going to increase the cost of retrievals. So when somebody goes to retrieve a file, we'll ding you. We'll hit you with a bigger charge there. But if it's really true that your users don't access that data very often, overall, you'll save money, right? The storage price is cheaper. The retrieval price goes up, but overall, you end up saving money if it's really true that your users don't access the data very often. Or you can do a 1-zone IA. Well, we're going to put your files just in 1 zone instead of 3 zones. You would be sacrificing high availability because now your data is just, what if that zone has a power outage, right? You would lose access to the data until it comes back up. So you'd be sacrificing some high availability by storing the data in 1 zone instead of 3 zones, but we make it cheaper, right? We make it cheaper for you. Or maybe you want to just move the data between classes automatically. You can use intelligent tiering. Amazon will automatically move the data between the classes so you don't have to worry about it. We'll manage it for you. And then we have Glacier. The Glacier tiers are intended for archives, for backups. Okay, so it has very low cost storage with really high retrieval fees, right? But when you back up data and store it in the cloud, odds are you'll never use it, right? I mean, isn't it true that you back up servers every night for years without ever using the backup, right? It's just there in case you need it. Then Glacier makes a lot of sense because it makes the storage space really cheap. The retrieval fees are high, but the storage space is really cheap. So again, in the long run, you end up saving money when you're using one of those classes for archive data or backup data. All right, so if I go back into my console for just a second here, right? When I store data inside my S3 bucket, I can choose which of these storage classes I want to use, right? They're all there. All right, we will move on to other things. All right, a little quiz question. You want to store data that is infrequently accessed, but must be immediately available when needed. Which Amazon S3 storage class should I use? All right, since it says infrequently accessed right there, all right, there's your clue. Yeah, I've seen a lot of C's coming in, and you're right, right? I mean, that's exactly what that particular storage class is intended for. Okay, data where, files that my users use, but they probably don't use them very often. That would be the most cost-effective solution given that scenario. All right, let's move on. File storage. All right, so here comes our third storage type, right? And then we're going to move on into databases. So here's the third way you can store files in the cloud. So we looked at block storage, a service known as EBS. Then we looked at object storage, a service known as S3. And now we're seeing file storage. This is where we're going to get into a service known as EFS, Elastic File System. Okay, with this particular storage type, what we're doing is we're creating a storage solution in the cloud that looks like a file server. You know how when you go to work, right, you sit down at your computer at work, and I don't know, you open up, your file explorer, your My Computer folder or whatever, and you see like an M drive or an S drive, right? That data is stored on a file server across the network from you, right? I mean, oftentimes we don't want users storing data on their own laptops. Because what happens if your laptop dies, or your hard drive dies, your laptop gets stolen, right? We want to store data on a network server. And so we've had network servers on our networks for decades now, right? We have what we call file servers. Some file servers are Windows-based, some are Linux-based. People also have network appliances that act like file servers, like you might have heard of a device called a NAS. It's just another type of file server. So what EFS is it's like a file server in the cloud, but there's no actual server. So you don't have to worry about patching or updating or scaling and making sure it has enough RAM or processing power. It's a serverless version of a file server. Your users see a file server, but there's no actual file server to manage. Right, so it's called EFS, Elastic File System. It'll scale all on its own. You could have thousands of users or instances potentially connecting to said file server. And it offers the data, the opportunity. You can choose if you want to do this or not, but you can replicate the data across multiple availability zones in order to provide high availability for that data. So even in the case of an availability zone failure, the data would still be available. All right, so this is a service known as EFS. What I want you to remember about it is that it provides what looks like a file server in the cloud, right? Everybody sees a file server, but it's really just a service you're running in AWS. There's no actual server you have to manage. All right, now let's move on to a different type of storage. So that was all file storage, okay? We looked at EBS, S3, EFS, different ways to store files in the cloud. Now we're gonna look at storing data in the cloud, like records of data using databases. So here you see on the left, just a simple table for a database, like a relational database here. And it looks like these are products maybe that we sell, right? Medium roast ground coffee, dark roast ground coffee, different sizes, different prices. And when we create a relational database, we will often have many other tables with other data. And then these tables get related to each other, usually by ID numbers. So I'm thinking of a database like SQL, Oracle, right? Those are both examples of relational databases. Now, those database technologies have been around for a long time. Relational database has been around for many decades, and it's a very reliable database service. People have been using it for years. People love it, and you're more than free to keep using it. But inside of AWS, we also offer non-relational databases. DynamoDB is probably the most famous of them, but we have some others as well. We'll talk a little bit more about some of the others a little later in the chapter. But we do offer what's called a non-relational database. A non-relational database stores data as key value pairs. Right? So you have a key, you have values, as opposed to a rigid table. Non-relational databases are a little bit more flexible. They give you a little bit more flexibility. In some cases, that's advantageous. In some cases, it's not advantageous. Always depends on the use case. But they give you a little bit more flexibility sometimes, while relational databases kind of force everything into these rigid tables all the time. And sometimes that can be constraining. Well, let's stick with the relational databases for a little bit, right? Let's stick with those, and then we'll come back and talk about some non-relational options, maybe in 5 or 10 minutes. Let me erase my scribbles, get the slide advanced here. There we go. Okay, so relational database. So like I said, a relational database is going to have a series of tables. This table is products. Maybe we have another table with customers in it. Maybe we have another table with orders in it, right? And maybe, I don't know, customer number 17 ordered this dark roast ground coffee, and they ordered, I don't know, 8 bags of it. All right, so maybe we have a table that stores the order, and you can see how the tables are related to each other, right? These ID numbers kind of get referenced inside of other tables, and then we call these the relationships between the tables. And then we use something like SQL to query the tables, right? So we create all these tables with relationships, then we use something like SQL to query those tables and pull data out. Like I said, relational databases have been around for a long time. Now, if I want to run a relational database in the cloud, I really want you to pay attention to what I'm about to say here, right? If I want to run a relational database in the cloud, I could build an EC2 instance and run a database on it, right? Install whatever database app I want. So I can build, a virtual server that runs Windows Server and then install Microsoft SQL Server on top, and now I have a database. But there's a recurring theme here, right? I keep saying, I've said it several times today, that if you could do something serverlessly, right? If I could do it serverlessly, then I wouldn't have to manage this server. I wouldn't have to update it. I wouldn't have to patch it. I wouldn't have to scale it. I wouldn't have to do any maintenance on it. So we offer in the cloud what we call relational database service. With relational database service, Amazon provides the database server. Okay, so the database server is provided by Amazon. And then Amazon updates it and patches it, installs the database application, upgrades the database application. We do all the maintenance on the server. Right? So you can take your administration and just focus on managing the database. Right? This server is managed by AWS. Right? And so there's a database running on top. You just focus on the database itself. You just focus on building your tables and building your queries. We can still store that database in an encrypted format. So we have security features built in. We build the database server and scale it to different sizes for you. So within Amazon RDS, what we call relational database service, you can run any of these database engines. Aurora, I see mentioned in the chat, but any of these others. Amazon Aurora is kind of an Amazon-specific database engine, but you can run Microsoft SQL Server, Oracle, or any of these open source. Maybe I'll just get my pen here. Like these three here are all kind of open source ones. So they're all cheaper, right? They're all cheaper options. There's not a lot of licensing fees and stuff, right? Oracle and Microsoft SQL Server are really nice products, but they are a little bit more expensive. Or you can run Aurora. Now, what's really nice about Aurora, I should mention, is it's really the only one that was developed for the cloud. Okay, all of those other database engines were designed to run on servers on-prem that have been ported over to the cloud, but Amazon Aurora was built for the cloud. So for example, Amazon Aurora knows to create 6 copies of your database across 3 availability zones. It's just built into the service. But it takes advantage of the fact that the AWS Cloud has multiple availability zones. It has really good storage performance. Really good storage performance because it takes advantage of the way storage works in the cloud, as opposed to all those other servers who kind of store data on their hard drives, right? I mean, database servers normally want to store data on their hard drives, but here we're going to take advantage of the storage systems that are available in the cloud. So Aurora can be a really nice option. It's the only one of the 6 engines, if I back up a slide, that's kind of designed for cloud. And so therefore, it's a really popular option. But we support all these too. Whatever you want to use, you get to pick. You're the customer. You get to choose. All right. But I want to emphasize once again that with all of these services, Amazon provides a database server and manages the database server. You just worry about the database. All right. What else can we discuss? Okay. So here we see just a little coffee shop example. So one of the employees at the coffee shop has an idea for a new inventory management system, and they believe they should create a text file and store it in S3. What do you think? For an inventory system, is that the best place to store your inventory system? I'll take yes or no answers in the chat. All right, so yeah, I'm starting to see some no's there. Yeah, I mean, you certainly could. I mean, it's your coffee shop. You can do it however you want. It's your environment. However, a text file in S3, boy, how am I going to query that? How am I going to connect applications to it? I think that'd be kind of clunky, right? I'm thinking a database would make more sense in this case. some kind of a database service. Now it's an inventory system, and maybe it's a really basic bare bones inventory system. So we do a pretty basic database, but it could also be really complex. But I'm not sure S3 makes the most sense, right? S3 is really intended to just store a file. Okay, let's move on to non-relationals. So we're looking at some different options when it comes to relational databases, but I also mentioned that there are non-relational databases. And one of the advantages of a non-relational database is, like I said, it gives you a little bit more flexibility. You're not always stuck to rigid tables. Okay, you know how, I mean, I don't know if all of you have dealt with this before or not in your careers, but I bet you some of you have. Like, let's imagine that I sell shirts, like polo shirts and t-shirts. And so I have a table, and one of the things we have on the table is a size column. And inside the size column, maybe some shirts are medium or small or large or extra large, whatever, right? And then we have maybe a color column. And so some of our shirts are red and some are green and some are blue, right? So we have, colors delineated here. And so, or maybe this is actually two different tables. I drew this as one table. It might even be two different tables, one that stores the sizes and one that stores the colors. But inevitably what happens is one day you buy shirts that have sleeve sizes. We start stocking shirts that have sleeve sizes, and we don't have anything in any of our tables to accommodate that. We have no way to reference shirt sleeve length. We don't have that, And so we start thinking about making a whole nother table just for the different shirt lengths, but it's only one shirt that I sell that has those special, it seems kind of crazy to make a whole new table for sleeve length when I only have one shirt that uses sleeve lengths. Well, with a non-relational database, you can just add another key pair, for that one shirt that none of the other shirts use. So it gives you a little bit more flexibility. It's not as rigid as working with tables. That's one advantage. The second advantage of using non-relational really busy, we can add more servers using an auto-scaling group and split the workload up with a load balancer. Well, there you go. That's DynamoDB. It auto-scales. It horizontally scales across lots of servers to handle massive workloads. It's a service that's designed automatically in the background without your intervention to automatically scale across many servers to handle really big workloads. So it can handle speeds that something like RDS can't keep up with. A lot of people don't need those speeds. If RDS meets your needs, that's great. But if you have a need for extreme speed with really big data sets, DynamoDB is really advantageous. All right, think about Zoom. I'm going to give you one more example, then we'll move on. Think about Zoom. Y'all know Zoom, right? That application where you do video conferencing. Well, when the COVID pandemic happened, right? So COVID happened a couple of years ago, and all of a sudden we were all staying at home, right? Nobody was going out. And so we were Zooming a lot more, right? Zooming with our friends and our families and with our business, our coworkers. And so at one point, Zoom had 300 million meetings per day. It's probably declined since then. But at the peak, 300 million meetings a day. So can you imagine going into Zoom and trying to pull my calendar? I just want to see my calendar of my Zoom meetings. And we have 300 million of records to sift through for each day, right? Which adds up to billions for a week or a month, as many billions, right? We need something that can handle extreme level requests and extreme level sifting through data. That's what DynamoDB is built for. And actually, they're one of our customers. Zoom uses DynamoDB for their meeting table. So that might be a database service you look into. Like I said, a lot of people don't need it. If you need that extreme level performance, DynamoDB can provide it. We also have a database migration service. This is used to help you migrate a database into the AWS Cloud, migrate it from wherever it's running into one of our relational database services. So here we have a MySQL database on the left, and we're using this database migration service to try to migrate it in. The migration service will migrate everything it can. Aurora is MySQL compatible, so this migration will probably go really smoothly. Sometimes when you're changing database products, though, some things can get imported, other things can't get imported. You have to kind of take that on a case-by-case basis. But we do have a service to help you do migrations. So let's do another set of little review questions here. So in this case, you're going to answer with RDS or DynamoDB. I want to store data in a relational database. Would I use RDS or DynamoDB? All right, I'm starting to see RDS there in the question and answer area, and you are correct. Yeah, if you want to use a relational database, well, that's relational database services. Okay. I want to run totally serverless. Totally serverless. Of the two services, which one is more serverless? DynamoDB is more serverless. You don't see the servers at all. Now with RDS, Amazon does manage the servers for you, but they still exist. You can decide how much memory and CPU. So some of the scaling stuff is still up to you to decide. DynamoDB is the more serverless of the two options. With DynamoDB, you would do less server administration. Okay, storing data in key value database. Does that sound like RDS or does that sound like DynamoDB? Storing data instead of tables using key value pairs? That sounds like, yeah, I've seen a lot of DynamoDB there in the chat. Well done once again. DynamoDB is correct. Using SQL to organize data, would that be RDS or DynamoDB? Using SQL. Yeah, SQL is more of an RDS thing. Sometimes people actually, when we talk about non-relational database, sometimes people call them NoSQL databases. All right, so SQL is more of a traditional database, more RDS. All right, scaling up to 10 trillion requests per day. We're going on to number 5 now. 10 trillion requests per day. Which one can do it? All right, I like what I'm seeing. I'm seeing a lot of DynamoDB, and you are correct. And then lastly, which one is Aurora considered? So is Aurora considered part, is it one of the RDS services, one of the RDS engines, or is it part of DynamoDB? Where does Aurora fit? So number 6 here, storing data in an Aurora database. Yeah, that's part of RDS. It's one of the engines at RDS. Good job. All right, well done. All right, well, I'll tell you what, it's about time we take our first break of the afternoon. So we're going to take a little break here. When we come back, we're going to wrap this chapter up. We're really close to the end of the chapter. We just have a couple slides to look at, and then we'll do our little knowledge check. And then we're going to move on into other topics. We're going to do security, pricing is still coming, monitoring is still coming. So we have a lot of cool stuff still lined up for you. But let's get the timer on the screen, and let's take our 10-minute break, and I will see you all when the timer runs out. All right, enjoy your break. End of module 5. We just have a few more slides to look at here. And then we're going to get on into security and some other topics. Remember, we have 10 modules all together. And we're just about done with module 5 here, which sounds like we're way behind, but we're actually right on schedule. What's going to happen is some of the later chapters go a lot faster. They're a little shorter. They go a lot faster than the earlier chapters, so no need to worry about that at all. And let's get started. And you know what I should do real quick before I get started? I just want to give a quick thank you to everybody in the chat, especially our support team. So Paulie, Matt, Zach, big thank you. Big round of applause for all of you, because I know I've been on your side of it too. And keeping up with all those questions in the chat when we have this big a group with hundreds of people in the room is not an easy task. So well done. Thank you for all the help in the chat. So let's get started with additional database services. So we just have a couple more slides left in this chapter where we mention some other database services that we offer in the cloud. All right, Redshift is a data warehouse service, right? A managed data warehouse service. Neptune is a pretty popular database service in things like social media. Okay, data sets with lots of connections or relationships. We have DocumentDB, which can store data in the form of JSON files. QLDB, Quantum Ledger database, which might be popular in finance. And we have even more, right? We have an Elasticache and DynamoDB Accelerator. These are both kind of caching services to speed up access to databases. And we even have a blockchain service. So just letting you know that there's lots of database services to choose from. Relational database services are obviously the most common, the most heavily used. But sometimes, depending on the kind of data you're trying to work with, you might find that one of these other data services suits that data better. All right, let's do our knowledge check. So which Amazon S3 storage classes are optimized for archival or backup data? Which Amazon S3 storage classes are optimized for archival or backup data? Two correct answers here. Yeah, good job. I like what I'm seeing there. The answers that are coming in, I'm seeing a lot of Glacier, right? Glacier is really designed for backup data or archive data. So both those Glacier answers are good. B and D, well done. Which option is true about Amazon EBS volumes and Amazon EFS file systems? Ooh, that's gonna be a tough one. See who remembers, see whose memory is best. I did tell you about availability zones, but we'll see who remembers. All right, I'm starting to see some answers coming in now. Good, I like it. Yeah, the answer is actually A. EBS volumes are stored within a single availability zone. EFS volumes at least offer the option to store data in multiple availability zones. Yeah, so it's A. Good job. All right, let's do another one. A customer wants to store data in an object storage service. Which AWS service should the customer use for this type of storage? So who remembers which one is called object storage? I agree, right? S3 does object storage. Good job. Which statement describes Amazon DynamoDB? Which one describes DynamoDB? Oh, I like B here. I've seen some B's there in the chat. I think that's the most popular answer that's coming in so far. B is right. It's serverless, and it's a key value style database. Instead of using rigid tables, it's not relational, not SQL. All right, good. I think we just have one more. Which service is used to query and analyze data across a data warehouse? I very briefly mentioned it. Which one of those is a data warehouse service? All right. Yeah, a few people remember. Yeah, I mean, I'll go back. All right, now everybody remembers. Right now you got it right there on the screen. Data warehouse is Redshift. Okay, good. So the answer for that one was Redshift. I'll see if I get back to the right slide. There we go. Choice D or Redshift. All right, well done. So that was it for Module 5. In that chapter, we talked about storage and we talked about databases. All right, let's move on to a new one here. And this one's going to be about security. All right, should be able to see the new PowerPoints right about now. And so in this chapter, we're going to talk